All right. What? What? So we're going to do a no simplifications. We're not going to clean this up. No simplifications on these answers, okay? These will not be simplified at all. We're just looking for a pattern and how they're going to work. Here we go. Y prime. And these are going to get huge. Huge, huge, and freaking huge. So here's how the game works. Take a derivative on the outside, and then you rewrite everything else because it's the inside. 1, 2, 3. There's the 1, the 2, 3, and there's the 4. Okay. Cool. Now you know what you do. You move to the next. And you go, what's the derivative of cosine? Negative sine of. And now you leave everything else alone. Tangent of secant of 2x. 1, 2, 3. And there's the fourth. 1. So there's for this one, for that one, for that one, for that. Okay, got it. Now we just keep moving in. We keep moving in. What's next? There it is. So now we'll take a derivative on tangent. That's going to be secant squared. Oops, let me write it in blue just to show you that we're moving to that one now. Secant squared of, and what's left? Secant of 2x. We're not done. Let's move to the next. And the derivative of secant is secant tangent. Oh, am I running out of room? I'm going into the next freaking problem. And then we're going to leave those two x's alone. Now we just need to multiply by the derivative of 2x times 2. So clearly, right? Clearly that's the answer. Now that you see, you're like, oh, of course. Of course. How could I have been so silly to not see that? Do you know what this model's here? You know what this model's right here? Absolutely nothing. I'm just being a math teacher and showing you kind of like how a pattern is going to work. There's no freaking application to this. You don't put trig functions in trig functions. You put inverse trig functions into trig functions and trig functions into inverse trig functions. This is a bunch of freaking nonsense. Yeah. Wait till you get to n-dimensional. Yeah, never mind. Oh gosh. What fresh hell we stepped into here. These are supposed to. They are designed to be awful. So this cube. What might be helpful is if you wrote it like this and threw that all the way on the outside of it. Maybe, so notice how I'm just using parentheses. Maybe you're like, I'm going to start using brackets so I can keep track of everything. And you take that to the third power to the outside. So now our y prime is let that 3 fall to the front. And now we're going to leave all this stuff alone. We're not doing anything with it yet. And then there it is. And now we've lost the power. Okay, cool. Now we're going to go into our next one. I always want to say it's like peeling an onion from the, like, you know, have you ever seen Shrek? Yeah, okay, whatever. That's kind of what we're doing. We're working from the outside. It's cool. So now we're going to take this and we're going to take a derivative on it. And the derivative of tangent is still, again, it's still secant squared of. And we're going to leave all that stuff that's in black in there. The x cubed e to the x plus cosecant of x. Wow, I messed that one up to the fourth. Okay, cool. Now let's go. So we handled that. We're to the secant. Now what's left in black? Oh, now we got to handle that. Do you mind? Maybe we'll go aside and do this one. Maybe we'll write aside. Let's go aside. So x cubed times e to the x. Maybe we'll mess with that. And we do one of these, x cubed, e to the x. We get our 3x squared. We get our e to the x. Okay, cool. We can go find that now, right? Using that little trick. So maybe we start writing that down. What's that? X cubed times e to the x. X cubed times e to the x. Plus, what's that? 3x squared times e to the x. And remember, we're not cleaning this up. So we handle the We handled that derivative, but we still need to get that cosecant one. That cosecant one. So how are we going to get that derivative? What's cosecant of x to the fourth? What's the derivative there if that's y? Y prime is going to be the derivative of cosecant. Is that one? That's negative cosecant cotangent. And then we need to multiply by the derivative of the inside. So there we be. You punch that in and we're good to go. I can never help myself. I'm going to just have to write it for, I put the negative 4x cubed at the beginning. Cosecant of x to the fourth. Cotangent of x to the fourth. What? Gosh dang. And again, clearly, right? Clearly, you are the only person watching this video right now going, that was tough. Everybody else thinks it's super. Of course not. I used to think that sort of stuff, like, oh, it's just me, I'm struggling. Nah, this is tough. It's purposely. I'm being an asshole, making it so rough that when you deal with something that's a lot more minor, it's not going to feel so rough. So, yes, these are some miserable, miserable freaking problems.